Okay, then. So let's get started. Hello and welcome to one and all to this AWS reInvent recap session. My name is Johan, and today I'm going to be walking you through some of the important and useful AWS service announcements that we have released during last year's reInvent. Today's session will be split into two main sections. The first will cover the major infrastructure related features and services, such as compute, storage, containers, etc., followed by my colleague Vincent's session that will cover security and networking announcements. We are also having a follow up session on databases and AI ML services on the 28th of Jan. So please do register for the same if you haven't done so. Throughout the session, we shall also be asking a few simple poll questions just to gauge, which AWS services are of most interest to you. And towards the end of the session, there will also be a short survey. The survey helps us as solution architects to best deliver such content to our customers. So do take a minute of your time and provide us, with your valuable inputs. A big thank you upfront for the same. Last but not the least, a very quick note on housekeeping as well. So, due to the large number of participants, you would all be muted by default. However, if you have questions or any queries pertaining to the announcements, then please feel free to use the questions section or the chat functionality that is provided within GoToWebinar. We will try and answer most of your questions during the call itself. And if we aren't able to, then we would get back to you via email as well. So, what have we in store for today? Well, the first 1 hour or so, we will look at some of the new services as well as features that were announced in the compute, storage, containers, and last but not the least, the hybrid field. Just a small reminder again that there are still many other smaller features or announcements besides the ones that we are covering out here today with you. But we have curated and customized this 2-day event, keeping most of your current workloads and services in mind. Still, if you have any queries or wish to learn more about any of the AWS's service covered today, or even in general, then don't hesitate to contact us. We are more than happy to help out. Keeping this in mind, let's get started with some really cool announcements in the compute area. So obviously the first launch of reInvent 2020 was the surprise introduction of Amazon EC2 Mac instances. Just a quick primer on the EC2 Mac instances. So Amazon EC2 Mac instances enable customers to run on-demand Mac OS workloads in the AWS cloud, basically extending the flexibility, scalability, and cost benefits of AWS to all Apple developers. The primary use case for the Mac instances is basically application development for the Apple platform. So if you're developing for iPhone, iPad, Mac, Apple Watch, Apple TV, so on and so forth, then customers would primarily be interested in the EC2 Mac instances to build, test, sign, and publish their applications on the Apple platform. We also announced a few other EC2 instance types, such as the Amazon EC2 C6GN instances, that are basically the latest addition to the Graviton 2 instance family, delivering up to 100 Gbps of network bandwidth, up to 38 Gbps of Amazon Elastic Block Store bandwidth, and all of this with 40% price to performance cost savings as well. We also launched Amazon EC2 M5ZN instances. Now, these instances reduce software license cost by right-sizing workloads on fewer vCPUs. At the same time, they provide roughly 45% better price performance than the previous M5 instance types. The M5ZN instances are available in 7 sizes, ranging from anywhere between 2 to 48 vCPUs and 8 to 192 gigabits of memory as well. And similar to their predecessors, they also provide roughly 45% better single-threaded compute performance than the previous EC2 M5 instances. Additional to these, we also announced the general availability of the Amazon D3 and D3EN instances. So these instances provide cost-effective, high-capacity local storage for massively scaled storage workloads, including big data, analytics, data warehousing, and high-scale file systems. And last but not the least, we also announced Amazon R5B instances. So the R5B instance type provides the fastest EBS performance on EC2. So in terms of compute capabilities, these are the same R5 instance types designed for a larger memory requirement. However, the EBS performance is roughly 3 times faster compared to your standard R5s. Moving on, for folks who have not come across or heard of AWS Lambda. So AWS Lambda is basically a serverless compute service that lets you run code without managing the underlying infrastructure. With Lambda, you can write and run code in your favorite programming language. You simply choose the memory allocation required, and Lambda will automatically allocate those resources on your behalf. For example, CPU, network, I/O, all of this is provisioned for you. It's really that simple. There are over 140 AWS services that can trigger Lambda functions, or you can even invoke them on your own as well. Now, prior to reInvent, AWS Lambda supported only 3 gigabits of RAM and 2 vCPUs. Now, this has been drastically upgraded to 10 GB of RAM and up to 6 vCPUs. This enables customers to run much larger workloads, process bigger assets, and use more CPU in parallel as well. In addition to this, Lambda also now supports something called as the Advanced Vector Extensions, or AVX2. This also allows increased CPU performance for very specialized tasks such as AI/ML, media processing, scientific computing, or other CPU-intensive tasks as well. We also introduced Lambda billing in 1 millisecond increments with no minimums. So previously, customers were billed in 100 millisecond increments. However, this new change allows customers to realize immediate cost savings on most Lambda functions and to obtain more cost savings through, let's say, code and configuration optimizations. Apart from these new updates, perhaps the coolest announcement to come up with within the reInvent was the introduction of Lambda containers. So AWS Lambda now supports packaging and deploying of functions as a container image, making it much easier for customers to build Lambda-based applications by using familiar container tooling, workflows, and dependencies. So this essentially enables customers to use a consistent set of tools with both their Lambda and containerized applications, thus providing for central governance requirements such as security scanning and image signing. So customers can create their container images by starting with either AWS Lambda provided base images or by using one of their preferred community or private enterprise images as well. Now, it's important to note over here that customers can still continue to use their current Lambda function deployment process, which basically involve creating of zip archives and developing and deploying them using the console. There is no change to these processes at all. The containers is just another way of, let's say, deploying or making it easier for you to deploy your Lambda functions on AWS. Cool. So with the compute set and done, let's have a quick look at what new services and announcements were made in the storage area as well. Now, for people who are new to AWS, it's important to know that we provide a broad set of cloud storage options, each with its own deep set of functionality, security, reliability, cost, and performance. For example, for object storage, you can aggregate terabytes, petabytes, or even exabytes of data very cost effectively into Amazon S3 and then drive value from that particular data lake. We also offer Amazon EBS that provides the highest performance block storage with the highest capacity of IOPS and throughput among any major cloud vendors. And similarly, for file storage, we offer services such as FSX for Windows File Server, Amazon FSX for Lustre, and Amazon EFS as well. Now, these services offer the lowest cost SMB and NFS file storage in the cloud, and they are perfect fit for your NAS type of migrations as well. Now, it's again important to note here that all of our storage services remove undifferentiated heavy lifting, capital acquisition costs, operational overhead, and scalability challenges that customers face with traditional on-premise solutions. And we provide all of this value and agility with the simplicity of a click of a mouse or by making just a few simple API calls. Now, just to set the context and a very quick recap, we think that block storage is a foundational requirement for most of your workloads. And we offer different types of block storage that you can select and use based on your requirements, such as the general purpose SSD volumes, which are our most popular volumes, and they are a great fit for a majority of your workloads, including transactional, low latency, interactive apps, as well as boot volumes. Then we also have the provisioned IOPS SSD volumes that are built for IO intensive workloads that need consistent and high performance block storage. And finally, we also provide customers with throughput optimized HDDs as well as cold HDD volumes that are designed for throughput oriented workloads as well as data which is infrequently accessed. So let's dive a little deeper into the general purpose SSDs. So we launched GP2 in 2014, and it quickly became our most popular volume type. Customers love the simplicity of buying storage capacity and getting throughput and IOPS bundled with it. But they didn't like how you had to buy more storage to get more performance. It meant that customers were paying for more storage than they needed in order to get the performance that they wanted. So we wanted to create a way to decouple IOPS performance from storage capacity. And with that, I'm really pleased to introduce you to the new GP3 volumes. So the GP3 volumes are the next generation general purpose volumes that deliver up to 4 times higher peak throughput than the GP2 volume types. And also now include a baseline performance of 3000 IOPS for each volume. If you're fine with your storage capacity, but you need more performance to go with it, with GP3, you simply right-click in the console and modify the volume to provision the IOPS or throughput as you need without having to add more storage capacity to it. So that means that customers can now save cost by provisioning only the IOPS, throughput, or storage as they need. And we have also reduced the price per GB of GP3 volume types by 20%. Now, we think that customers love GP3, but there are some workloads like clustered databases where customers need even more IOPS than they can get with GP3. And that is why we created something called as the provisioned IOPS volume type. Now, a few months ago, we launched IO2, which is our latest generation of provisioned IOPS SSD volumes. It delivers 4 times more IOPS than our general purpose volumes and are ideal for performance intensive business critical applications such as SAP HANA, Microsoft SQL Server, as well as Oracle databases. Now, what customers are very excited about is that IO2 is our first EBS volume with a design of 5 nines of durability. That's 100 times more than the previous generation IO1 volumes, but you get this at the same price as the IO1 volumes were. So at reInvent, we lowered the cost of EBS again by also introducing something called as the tiered pricing for IO2 volumes. Previously, all the provisioned IOPS on a single volume were charged at a single rate. But now with the tiered pricing structure, the first 32,000 IOPS provisioned on a volume are charged at the current base rate. And then the second tier between 32,001 and 64,000 IOPS is charged at a 30% lower rate, and then so on and so forth. So this means that we are giving approximately incremental 30% discounts per volume tier of IOPS. Now, although we like to lower prices, our innovation curve for IO2 extends beyond the price. So we are also innovating on capabilities as well. We recently introduced multi-attach on IO2 volumes. So with multi-attach on IO2 volumes, you can now attach a single volume concurrently to up to 16 AWS Nitro-based EC2 instances within the same availability zone. So each attached instance has full read and write permission to the shared volume, which makes it really easier to achieve higher application availability. Now, with all this innovation on IO2, you can tell that we are doing something unique and different with block storage in the cloud. But there are still applications that even IO2 can't support without having to combine multiple volumes together. While that's possible to do so, it adds management overhead. So to run very high performance applications on premises, customers would have to historically relied on SANs. But SANs are again expensive with a big fixed cost upfront, regardless of your utilization. And also that the minute you exceed capacity, there is yet another big fixed cost. Also, SANs are very hard to manage yourself. You have to update the hardware and the software as the SAN reaches their end of life. Now, upgrading can be also very disruptive. You also have to make them fault tolerant across multiple data centers, which again adds to data center costs. So customers don't like having to manage these SANs or be forced to keep them on premises, but have felt that they have no choice because there isn't a block storage with the performance of the SAN in cloud. Well, I'm very happy and excited to announce that we also released something called as the IO2 Block Express, which is essentially the first SAN built in for the cloud. IO2 Block Express is a feature in preview for the IO2 volume users. It increases the performance of your IO2 volumes by 4 times across your performance dimensions. So that means that you can now run your most demanding IO intensive workloads in the cloud, including mission critical workloads of Oracle, SAP HANA, Microsoft SQL, uh, applications that today rely on a SAN. You can now get 4 times the IOPS, the throughput and capacity of IO2 in a single volume. That is essentially 4 times better, however, at the same price. So IO2 Block Express gives you the performance of a SAN in the cloud without any of the headaches. So no one else has anything that delivers, that same type of performance and capacity of IO2 Block Express. In the coming months, we also plan to release support for additional SAN features, including multi-attach, IO fencing, fast snapshot, restore, as well as elastic volumes. So just to recap, it's been a big year for the EBS team as we journey to SAN in the cloud. We started by launching the new IO2 volumes in August, and at reInvent, we are actually happy to introduce support for multi-attach and a preview for IO2 Block Express as well. We are also excited to introduce our most powerful EBS optimized EC2 instance, the R5B instances, which matches the performance of IO2 Block Express to provide you the necessary pairing that you need for your highest performance workloads. So moving on from block storage to object storage now. Now, S3 intelligent tiering is something that's widely adopted by all of our data lake customers. It basically charges for storage in 2 pricing tiers, one for frequent access and the other one for infrequent access. However, many customers have storage that is accessed very rarely and use S3 Glacier or S3 Glacier Deep Archive to reduce storage costs for their archive data. Now, to address customer needs, we just launched last month 2 new S3 intelligent tiering automatic archival tiers, which are called as Archive and Deep Archive. They provide this. They come at the same price and performance as the S3 Glacier and S3 Glacier Deep Archive, and customers can opt in to either one or both archive access tiers as well. Once activated, the S3 intelligent tiering will automatically move objects that have not been accessed for the last 90 days to the archive access tier. And after 180 days, the deep archive access tier. So this ends up saving up to 95% on storage for these rarely accessed objects. Now, the best part is that there are no retrieval fees when you are using the S3 intelligent tiering, and there are no additional tiering fees when objects are moved between access tiers as well. For data lake customers, most of them use S3 to store large shared data sets across tens of hundreds of accounts and buckets in multiple regions and thousands of prefixes. Now, before our launch of S3 Storage Lens just a few weeks back, customers would build custom applications to aggregate data to report on the storage growth patterns for the data lakes and for the shared data sets. Now, we launched Amazon Storage Lens to give you and your operational teams an organization-wide visibility into your object storage usage with a few clicks in the AWS Management Console. So S3 Storage Lens is the first cloud storage analytics solutions built natively into S3. And it gives you a single view of object storage usage and activity metrics, along with trends across tens of hundreds of accounts within an organization. And it also allows you to drill down and generate insights at the account, bucket, or even at the prefix level. It provides dashboards with roughly 30 plus metrics to show storage usage and activity trends. And it also provides you with some actionable recommendations for data protection and cost efficiency. So you can easily get the answers to questions like how much has my overall storage increased in the past 90 days? And drill down into questions like which prefix is growing the fastest out of my account. So you can do all of these things and much more with the help of Amazon Storage Lens. We also launched something called as the S3 bucket keys, which makes it easier and cheaper to use KMS encryption for every object in your data lake. Now, we know that many of our data lakes have millions or even billions of objects that generate large volume of requests to the server-side encryption KMS. So instead of using an individual KMS encryption key for every object in S3 and making a call to KMS every time an S3 request is made against a KMS encrypted object, a bucket level key is generated by KMS and it is stored in S3 to create a unique data keys for objects in a bucket. So this essentially results in the reduction of traffic between S3 and KMS and also reduces the request cost for KMS-backed server-side encryption by literally up to 99%. For data lake applications, performance matters, and S3 pioneered cloud object storage with the high performance and virtually unlimited scalability with eventual consistency. Now, at reInvent, we are making S3 even better for data lakes with strong read after write and list consistency for all applications. So now S3 delivers strong consistency with no extra cost for customers, no changes for their applications, and no compromise on important things like regional isolation, which is very different from other cloud providers who ask you to make trade-offs to get strong consistency. Now, customers use S3 replication today to create a replica copy of their data within the same region or across different regions for backup, compliance requirements, or even for low latency performance for multi-region applications. Now, some customers also needed to replicate data to multiple destinations in order to meet data sovereignty requirements or to support collaboration between geographically distributed teams. That's why at reInvent, we are announcing S3 replication multi-destination. So customers no longer need to develop their own solution for duplicating data across multiple AWS regions. They can use S3 replication to replicate data to multiple buckets within the same AWS region, across multiple AWS regions, or a combination of both. So with S3 replication multi-destination, customers have an even simpler and more flexible solution to meet data compliance and residency requirements, lower storage costs by replicating objects to a lower priced storage class, and to build a data backup plan as well. Last but certainly not least, many customers also want to connect applications privately from on-premise to S3 without using public IP or proxy servers in their VPC. So very excited to announce that coming soon, S3 will be available using AWS Private Link. You can create a direct private connection to S3 from on-premise or in AWS using interface endpoints in your VPC. This will simplify your network architecture by essentially eliminating the need to use public IPs, configure firewall rules, or configure an internet gateway to access S3 from on-premise. Now, with all these recent news and announcements, we are making it even more cost-effective, more secure, more performant, and much easier to build your data lakes on S3 as well. So far, we have covered the block and object storage services. Now let's take a very quick look at the new announcements in the file storage space as well. So for all the new people joining today's call, Amazon EFS is a simple set and forget serverless shared file storage. Now, many of our customers use EFS to persist and share data from AWS containers and serverless applications with zero management required. So this enables developers to focus more on building their applications and not on the infrastructure. So throughout 2020, EFS has essentially integrated with almost all compute models, which includes the Elastic Container Service, Fargate, Lambda, Elastic Kubernetes Service, you name it. Now, one of the challenges our customers are telling us is that NAS sprawling happens in their data centers, and the management overhead associated with it is too great. Now, by moving your workloads like home directories and content management to the cloud, you remove the operational barrier of managing storage, so you can reduce cost and improve agility. That's exactly where we also have something called as Amazon FSx for Windows file server, which makes your NAS migrations much easy. So with Amazon FSx, we provide the same administrative features as you're basically used to on-premise with the added AWS benefits of scalability, availability, and performance. We also offer a range of flexible price and performance options to reduce the TCO, as well as other, let's say, advanced options like data dedupe, which customers are already seeing additional savings of 50%. Similarly, for compute-intensive workloads like machine learning, HPC, and other high-performance processing, our customers love FSx for Lustre. It provides low sub-millisecond latencies and tens of millions of IOPS. However, in April last year, we launched the HDD storage option, which brought our costs down to roughly 2.5 cents per gigabyte per month. And in November, we announced a new line of basically it's a live storage scaling feature. So customers can now more easily scale their file storage with just a click of a single button. Well, with all the breadth and depth of storage services, it would actually be a crime if I did not talk about how these services and data can be backed up in AWS as well. So AWS Backup is the central AWS platform that enables you to create policies that protect and manage your data for compliances. AWS Backup supports a wide range of AWS services. And in November, we also announced the support for FSx for Windows and FSx for Lustre. We also enable you to copy your secondary data across AWS accounts and regions to ensure business continuity. So our policies provide you with a single pane of glass from which you can survey your entire backup estate with real-time monitoring and auditor-ready reporting as well. Now, additional to this, in November, we launched cross-account backups as well. So using this, customers can now designate a central backup account for all your organization's backups, thus providing much greater control, governance, and resiliency for your workloads. Moving along and almost towards the end of the storage section, let's also look at some of the cool new additions to the data transfer and edge services as well. Now, I want to take some time and introduce you to the two newest members to the AWS storage family this year. So in June, we launched AWS Snowcone, which is the smallest member of the Snow family of devices. Snowcone is actually as small as a tissue box, weighing it roughly 4.5 pounds, and it comes with 8 terabytes of usable storage. It is a rugged, secure, and purpose built device for use outside of your traditional data center. So you can use it in your backpacks on first responders or for IoT and even for drone use cases. You can execute your compute applications at the edge and you can ship the devices with data to AWS, or you can even transfer data online with the help of AWS Data Sync. This being said, in September, we launched Amazon S3 on Outpost. So it delivers object storage to your on-premise AWS Outpost in order to meet local data processing and data residency needs. You use the same S3 APIs and features just as you would on Amazon S3 with S3 on Outpost as well. So now you can essentially store, secure, tag, retrieve, and control access to the data on your Outpost. Those are the two new services that we have added in 2020. But we have also innovated deeply within the existing Outpost portfolio as well. And that's something which we'll cover towards the end of this particular section. Now, we all know that customers' environments are complex and they need the right migration tool which fits their data and their applications. To meet customer needs, AWS offers the broadest and deepest data transfer and edge processing services and capabilities. So in 2020, we launched quite a few enhancements in this area as well. To start off, the AWS Transfer family provides fully managed support for file transfers directly into and out of Amazon S3. Earlier in the year, we launched AWS Transfer for FTPS and FTP to make it easier for you to migrate your file transfer workloads. On the AWS Data Sync, we also provided with something called as online data transfer. So as part of the AWS Snowcone launch in June, we announced that Data Sync comes pre-installed on your Snowcone devices, thus enabling you to transfer data online to and fro from the cloud. So obviously we have had a lot of, let's say, new announcements and new features that have been released in the storage arena. So keeping all these amazing new services in mind, what announcement do you feel is most important for your workloads right now? Can we just have a quick poll for the same? So based on the things that I just talked about, you have the following options. You have the GP3 volumes, you have the SAN, which is the IO2 Block Express. You have your data lake storage. So we talked about the intelligent peering and archivals. We also talked about S3 storage lens. And then we also covered something called as S3 strong consistency and multi-destination copy support. It's a multiple choice question, so feel free to tick as many of them as you feel like. We'll give it a few seconds and then we shall see the results as well. Okay, so we got the results, and not surprisingly, 54% are really interested in the GP3 volumes. And again, this is a part of, let's say, your well-architected, framework as well. So we try to optimize your infrastructure on a recurring basis, right? So if you're using GP2 volumes as of today, we can most probably help you on how to migrate from GP2 to GP3 for better performance, at the same time reducing your cost as well. Coming in at a close number two is data lake storage. So obviously there is a good amount of interest in data lakes within the customers. But more importantly, you again want to see how you can leverage intelligent tiering to, let's say, save on cost. Coming in at a third place, which is essentially a tie, is the SAN, so IO2 Block Express, as well as S3 strong consistency. And coming in at 21% was the S3 storage lens. So pretty interesting stats out there. And thank you once again for the quick poll. So moving on. So we have talked about some really interesting new services and announcements from the compute and storage point of view. Let us now, deep dive into the world of containers and see what's in store for us this year. To start off with, let me first introduce you to ROSA, or Red Hat OpenShift service on AWS. For folks who aren't familiar with Red Hat OpenShift, it is basically a container and application platform developed and supported by Red Hat. It's built on top of Red Hat Enterprise Linux and Kubernetes, which are essentially two of the largest and fastest growing open source projects in the world. And it also adds several services to offer a well-rounded platform experience out of the box. So these include cluster services such as monitoring, managing, updating the cluster, built-in CI/CD pipelines, logging, and many, many more things, right? An important point is that regardless of where customers run OpenShift, either on-premise or in the cloud, the experience remains consistent, which is one of the most highly sought after features. Now, as I mentioned, that there are two main ways of customers to deploy OpenShift clusters as of today, right? The first one is self-managed, meaning that the customer is responsible for the configuration of the infrastructure and environment, the installation of the platform, and the ongoing management of the system, including monitoring of the health of all the components, applying software updates, adjusting capacity, all these things. So we have something called as the OpenShift Container Platform, or OCP, which essentially includes an installer that facilitates this entire process. Now, this is a great option for customers with a need to customize the cluster installation or integration points and tooling, and also who have the skills and ability to do so. The alternative to this is something called as OpenShift Dedicated, which is a fully managed OpenShift experience. Now, with this option, the customer no longer is responsible for the installation, care, and maintenance of the platform. It is now managed completely by Red Hat's expert SRE teams. So this is a great option for customers who want to avoid managing the whole environment, and who actually prefer to focus on just building their applications. Well, so ROSA is a new option for people who want to consume OpenShift on AWS in the same way they consume other AWS services. It is similar to OpenShift Dedicated in the sense that it is a fully managed offering, but it introduces some important changes which are driven by customer feedback. So in addition to the benefits of OpenShift Dedicated, you gain the ability to kick off the cluster provisioning directly anytime you need one. And you only pay for the usage of the cluster. So there is no upfront commitment or payments required. If you no longer need a cluster, you can deprovision it and you will only be billed for the time it was running. In summary, ROSA provides all the benefits of OpenShift Dedicated, but it will be available directly on AWS for customers to deploy. The billing model is consumption based, as I mentioned earlier. So this deployment model is ideal for use cases that call for a cluster to run for a very limited time and then be toned down completely. Something similar to dev test environments on the cloud. Besides the availability to create clusters on the go, Rosa will also provide you with the ability to integrate with other AWS services such as database, analytics, machine learning, networking, mobile, etc., to build secure and scalable applications way faster. But that's not the only thing. It's also important to note that while this is a service jointly managed and supported by Red Hat and AWS, you will only have to deal with a single bill from a single vendor, that is AWS. So each AWS service supporting your cluster components and application requirements will be a separate billing line item, just like it is currently done, but now with the addition of the OpenShift subscription as well. So Rosa is available now for public preview. So if you're interested in giving this a go, then you can sign up for the same using the link provided here. Don't worry, we will be sharing the slides later on as well. Or alternatively, if you can always reach out to your AWS account team, and we would again be more than happy to arrange for a preview of the same as well. Now, if Rosa has piqued your interest, you will surely love the next two really cool announcements to come out of reInvent 2020. That is the introduction of Amazon EKS Distro and Amazon EKS Anywhere. Up first, let's take a quick look at what EKS Distro is all about. So our customers trust us to deliver a managed Kubernetes experience, right, in a performant, reliable, and secure manner. Now we deliver this with the help of Amazon EKS on the cloud. However, customers may have the need to run workloads on-premise as well. Now, managing these different Kubernetes environments adds to operational overhead, complexity, and limits the portability across their different locations. With this goal of providing our customers with a consistent Kubernetes experience across multiple locations, we are offering EKS Distro and EKS Anywhere. Now, EKS Distro is the same Kubernetes package used by Amazon EKS to create reliable and secure clusters. Now, with EKS Distro, customers get the same version of Kubernetes and basically the same version which is deployed by Amazon EKS with the latest updates, backporting of packages, as well as security fixes. So EKS Distro follows the same Kubernetes version release cycle as that of Amazon EKS, and it is also downloadable for free from GitHub. You can run EKS Distro in any environment, be it bare metal or on VMs as well. Now, important to note that EKS Distro takes upstream, which is essentially unmodified Kubernetes, and packages and configures it in a certain opinionated manner, which is called as a Kubernetes distribution, and then open sources it, right? So the difference between a fork and a distribution is an important one. A fork is an alternative upstream code base. A distribution, on the other hand, is an opinionated downstream code base. Think, for example, like very similar to Linux distros, for example, Ubuntu or Amazon Linux 2, or Hadoop distros, which are offered by Cloudera and also which are found in EMR. You may now have a question as to what exactly is packaged as a part of the EKS distro. Well, to get started, you are provided with an unforked version of Kubernetes that essentially contains the latest upstream updates as well as the extended security patching support. Releases of the EKS distro are in step with the versions and components used or recommended for use with Amazon EKS. Besides this, there are also additional core components such as etcd, etcd-ctl, which provide the management of the Kubernetes backend. And then you also get bundled along with that something like core DNS, an upstream container network interface, and an upstream container storage interface as a sidecar too. Besides the core components required to run and manage your Kubernetes cluster, EKS distro does not include the likes of tools such as EKS-ctl or the AWS official plugins for CNI and CSI, or even Amazon controllers for Kubernetes. As mentioned earlier, EKS distro just takes upstream or unmodified Kubernetes and packages and configures it in a certain unopinionated manner, thus creating a Kubernetes distribution, which is ultimately offered to you as open source. Some additional details with regards to EKS distro. The main question that customers often ask is, what is the difference between EKS, which is the AWS Kubernetes Cloud Service, and EKS distro? The main difference is how they are operated. Now, EKS is a fully managed Kubernetes platform, while EKS distro is available to install and manage yourself. So as I mentioned earlier, you can run EKS distro on-premise, in a cloud, or on your own systems too. EKS distro just provides a path of having essentially the same Amazon EKS Kubernetes distribution running wherever you need to run it. Now, as of date, you can essentially build EKS distro from its source code, or you can install EKS distro using KOps or any other supported installation method. Once EKS distro is running, you are responsible for managing and upgrading it yourself. For end users, however, running application is the same as with EKS, since the two support the same API versions and same set of components. Okay. Going on. So we now understand that EKS distro is basically a distribution of EKS that you can install and set up anywhere, including your on-prem or even the cloud, right? EKS Anywhere, on the other hand, extends EKS distro and provides an installable software package for creating and operating Kubernetes clusters on-premise, along with the necessary automation tooling that is required for cluster lifecycle as well. So EKS Anywhere brings a consistent AWS management experience to your data centers, building on the strengths of the EKS distro. Now, EKS Anywhere additionally saves you the complexity of buying or building your own management tooling to create multiple EKS distro-based clusters, to configure the operating environment, to update the software, to handle backup and recovery. All of these things are taken care of by EKS Anywhere. Keeping this in mind, what sort of workloads or use cases does EKS Anywhere fit well with? So workload migration from on-premise to cloud with EKS Anywhere, where customers can have the same EKS tooling on-premise, and this consistency provides a quicker on-ramp for their Kubernetes-based workloads to the cloud. Data sovereignty, where customers may want to keep their large data sets in the data center due to legal requirements concerning the location of the data, yet EKS Anywhere can help to move the stateless part of the application to the cloud while keeping the data on-prem. You can also train your models in the cloud and run inference on-premise. So with EKS Anywhere, customers can now combine the benefit and the best of both the worlds. So you can train your ML models in the cloud using, say, AWS managed services, and then use that trained ML model in your on-premise setup as well with the help of EKS Anywhere. Here is how the entire portfolio will look stacked one upon the other. So during day one release, EKS Anywhere will support running over VMware vSphere-based environments with the support for bare metal servers coming soon after general availability. As mentioned earlier, the EKS distro is the heart of our managed EKS on AWS service, and the same EKS distro is now going to be managed in your on-prem environment with the help of EKS Anywhere. Now we are aiming for both the EKS environments to be managed using the AWS EKS console. However, you will still be able to run EKS Anywhere in a fully disconnected mode as well. The Amazon EKS console will essentially provide you with a single pane of glass to see the status of your Kubernetes clusters, your applications, and your associated cloud resources. The console will put Kubernetes at the user's fingertips, making it very easy to understand all the different components and dependencies of your application and check that they are all properly deployed. So what to expect once the service goes generally available? Well, for one, you will have support in the form of 24 by 7 engineers who will work alongside your infrastructure engineers to keep your systems up and running. SAs such as myself will also be involved to help make sure that your infrastructure is meeting the best practices and that your environments are designed to handle the most mission critical workloads. And additional to that, we also think that this is a part of a much larger effort, and we'll also ensure that you have the right partners equipped to work with you on this as well. So before we move on to the next important announcement in the container space, I just wanted to leave you with this particular slide that talks about the various support as well as responsibilities that come up using EKS Anywhere as compared to other AWS services. So on the far right is your traditional model of leveraging EKS in the form of a managed service. So we have EKS backed by EC2 worker nodes, in which case you are responsible for the data plane as you are essentially deploying your containers on EC2 instances. And then you can also use you can also leverage the entire end-to-end management over to AWS if you run the workloads on EKS coupled with Fargate. In that case, the data plane, the control plane, everything is part of AWS's responsibility. The same can thus also be applied on the left-hand side of the slide, where you can choose to run EKS either using Outpost as a managed service, or you can opt for EKS Anywhere, or you can just opt for EKS Distro as well. In which case, you as the customer are more or less responsible for the control plane and the data plane. The only difference here being the AWS support that is offered out of the box if you choose EKS Anywhere. So with that part over, we now know how and where we can run container workloads using EKS. But what about container images? Where do we end up storing them? So before we go into the new service announcement, just a very quick recap of some important terms and terminologies when it comes to containers and container images. So what exactly is a container image? Container image is nothing but a self-contained piece of software that has everything in it which is required to run. Okay, so it has the code, it has the dependencies, the tools, the necessary code, runtime, everything. Now you can create multiple containers of the same type from a single container image, and you can create multiple container images based on your workload requirements, such as one container image for a web tier of my application, the another one for the business tier, the another one for the database tier, and so on and so forth. Now, these container images are stored and made available to others for use using something called as a container registry. So once you have your container image ready, you would then push them into the registry. And conversely, when you wish to run the containers on a compute platform, you would need to pull the images and then spawn containers from that. So customers as of today already leverage something called as Amazon ECR, which is a fully managed container registry that makes it very easy to store, manage, share, and deploy your container images and artifacts anywhere. Now, Amazon ECR eliminates the need to operate your own container repository or worry about scaling the underlying infrastructure. So your images are stored in a highly available and high performance architecture, allowing you to reliably deploy images for your container applications that can then be hosted on AWS Fargate or ECS or even EKS. So one of the key announcements to come out of reInvent 2020 was the availability of ECR public registries. So with ECR public registries, customers can now store and distribute OCI compliant images in a globally accessible registry. This includes, but it is not limited to, Docker images, Helm charts, as well as OPA bundles. We also now provide something called as the ECR public gallery, where you can discover and use container software that vendors, open source projects, and community developers share publicly. Popular base images such as operating systems, AWS published images, Kubernetes add-ons, Helm charts, all of these can be found in the gallery. And the best part is you do not need an AWS account to search or pull for a public image. However, if you're using your account to basically do the same, it really makes it easier and faster to use public container software. In the future, the public registry will add support for a pull through cache, which will allow customers and partners to cache images from other registries, for example, Docker Hub, into the ECR public registry. So, this new capability will facilitate the migration of images to ECR as they are pulled. So, just a very quick look at what's actually happening behind the scenes. When you push an image to the ECR public repository, the images and artifacts are stored in Amazon S3. Now, Amazon S3 is designed for extremely high data durability because it automatically creates and stores copy of all S3 objects across multiple systems. So this means that your data is available when needed and protected against failure or errors as well as threats. So ECR can also automatically replicate your data to multiple AWS regions for high availability as well as faster retrieval times. Now, when an image is pulled, the service will automatically redirect the callers to the nearest replica of the image repository. And all this happens in a transparent and completely abstracted way. So ECR Public leverages Amazon CloudFront behind the scenes as well for caching. And this actually also helps in reducing the time spent on image pulls. Now, moving along, here's the last and, in my opinion, one of the best services to come out from this year's reInvent. So, introducing AWS Proton. Now, you would all agree that putting controls around applications and investing in developer productivity is not new, right? The problem is that existing solutions don't strike the right balance for companies with large deployment teams or fast growing application portfolios that are using modern container or serverless architectures. So, on one hand, you have the full and flexible infrastructure as a service where developers can do anything they want as long as they do it themselves. And on the other end, you have a lockdown platform as a service where the platform team has made all the decisions which make it easier for developers to run code, but hard for them to innovate. So what Proton does is Proton strikes a balance on the needs of operators for control and the developers for flexibility. So AWS Proton is the first fully managed application deployment service for containers and serverless applications. Proton essentially enables platform teams to give developers an easy way to deploy their code using containers and serverless technologies, using the management tools, governance, and visibility needed to ensure consistent standards and best practices. We spent a lot of time talking to our larger customers that have built their own internal developer platforms and shared services platforms to get this right. And so Proton has a set of core features that helps strike that balance for operator control with developer productivity, including a very familiar self-service developer interface, centralized management for operators, one-click upgrades to new versions when the templates are updated, deep integration with CI/CD pipelines, and of course, we also make it easy to support third-party tools and integrations. Templates are the heart of Proton. They help define the stacks that the development team will be deploying their services into and include the ability to tie together infrastructure as code, for example, with the help of CloudFormation, code pipeline, and of course, various other observabilities as well. So we want to make it as easy as possible for you to give your development teams great templates. And so we have a growing library of open source templates that are architected and production ready. We are starting with the common container and serverless use cases, and we'll expand this library over time based on the customer feedback. Now, let's take a simple walkthrough of how Proton works from an operations perspective. So you start off by having operators or your platform teams create and register their templates in Proton, which by the time we go generally available will be down to the granular AWS account levels. Now, operators are then able to see every service that has been deployed by their developers in Proton, including what template versions they are running and the state of the environment, whether it is running stalled or stopped due to an error, etc. Now, here is an example of the operator's view that shows the service templates that have been registered, as well as a summary of deployments that have been made using a very specific template. Now, Proton makes it very easy for operators to identify these deployments that are running out of date or they're using, let's say, backtrack templates. And it also helps them update to the latest version directly from the operator console. Now that we have seen a quick peek of what's it like from an operator's perspective, let's look at how things work out from a developer's perspective. So unlike other solutions in Proton, your developers won't need to be experts on the underlying infrastructure or learn how to properly create and manage infrastructure as a code templates like CloudFormation. That's all abstracted for them. All they need to do is select the template they want to use, input a few parameters within the guardrails the operators have set, and deploy their service. Proton takes care of the entire pipeline, provisioning the infrastructure, and deploys their code to the new environment. So developers that are already familiar with AWS will feel right at home with AWS Proton because it is built as a part of the AWS Management Console and part of the AWS CLI tools as well. There's nothing new to learn or integrate over here. Now, once a developer deploys their code with Proton, they are able to see all the services that are running, easily see if there are updates available to the templates and the status of their builds, all from one place. And when they need to make changes or redeploy with a new configuration, that is handled all within Proton itself. AWS Proton is now available in preview in US East, US West, and in Europe in the Ireland region. It is free of charge, and you only need to pay for the underlying services and resources that you consume. So if you're looking to get started with Proton, here are some interesting links for you to use. As always, if you require any additional deep dive sessions or have any questions pertaining around the service, feel free to get in touch with the AWS account team and we will be more than happy to set up a following call. Keeping this in mind, let's have a quick poll question on this as well. So considering all the container service announcements that you have heard so far, which particular service or let's say feature would have most interest to you? So we talked about Red Hat OpenShift available as a managed service on AWS. And we also talked about EKS distro, the distribution, and EKS anywhere, which essentially allows you to run EKS in your on-premise environments. We looked at ECR public, which is again a container registry where you can store your images. And we also talked about AWS Proton. So that's basically all about application deployment when it comes to containers and serverless applications. So we'll give it a few seconds and then we'll see the results. Okay. Oh, wow, that's a pretty interesting result over there. So the first place goes to 62%, which is people are really interested in understanding how AWS Proton can be used from an operator and a developer perspective. So that's coming in at number one. The second most popular is at 55%, which is Red Hat OpenShift service on AWS. Followed in by the EKS distro and EKS anywhere, and last but not the least, ECR public. So it's really interesting to know that the customers are essentially looking for a more managed way of deploying as well as running containers and serverless applications on the AWS cloud. So thanks for that. Okay, quickly moving on to the last section, which is basically all about hybrid. So we talked about compute storage and container announcements. Now let's just go through the hybrid slides as well before we hand over to Vincent for his part. So we are seeing an evolution where customers have a continuum of applications that are either easier or harder to move to the cloud. Now, in this continuum, workloads on the left-hand side are easier to migrate to the cloud and often include everything from back office applications to SaaS applications delivered to mobile devices. The right-hand side addresses workloads that are harder to migrate, whether that's because of low latency or local data processing needs for workloads, or it may be that those particular workloads run on factory floors for automated operations in manufacturing, real-time medical imaging, so on and so forth. And in the middle somewhere, we have workloads that could either use a cloud or an on-prem solution, depending on what's available in that particular region. So this type of situation usually involves data that needs to remain in a particular country, state, or municipality for regulatory or contractual or information security reasons, right? So at AWS, when we think about the application continuum, we also need to have infrastructure and services continuum to help run the applications wherever you need to, right? So starting off with the AWS regions that serve most customer use cases and then extending out to the farthest part of the edge with the help of IoT and disconnected environments. So we are also building out services in the middle tier where customers need AWS infrastructure and services on-prem in large metro centers, near end users, 5G networks, so on and so forth, right? From all the tasks that we have with our from all the talks that we have had with our customer, we see that there are three main reasons that dictate why applications must remain on-prem. First is latency sensitive applications. So some of your business critical applications are sensitive to latency and variability in latency. The second being local data processing and data integrity needs. So there has basically been an exponential increase in the data that is being generated by users and end devices. So how do you basically collect and process hundreds of terabytes of data per day without essentially having to transfer all of this data to the cloud? And the third is basically applications with data residency requirements. So you may operate in a geographical jurisdiction where regulations dictate that data and infrastructure reside in a specific country, right? So how do you take care of those things? That's precisely where AWS Outposts fits into the solution. So Outposts enables you to develop once and deploy in the AWS cloud or your on-premise without having to rewrite your applications. So with AWS Outpost, you have the same hardware and software infrastructure and a consistent set of services and tools across your AWS cloud and the on-prem environments in order to build and run modern cloud native applications anywhere. Now, Outposts are fully managed and supported by AWS, and AWS automatically manages and updates AWS Outposts as a part of its ongoing operations in that particular region. You do not have to worry about updating or patching this type of infrastructure. So what does Outpost essentially look like? It comes in form of a 42U rack form. It's fully assembled, ready to be rolled into position. All that happens is AWS associate will show up at your data center at a particular coordinated time with the rack. They roll it in, they plug in the power and network. It comes with its own centralized redundant power conversion unit, and it has redundant active components such as switches and spare capacity as well. Now, at this year's reInvent, we introduced the arrival of AWS Outpost 1U and 2U form factors. The new form factors will be generally available later in 2021. So with Outpost Server, customers can use the same AWS APIs, the tools, the services to build and deploy applications to smaller or space constrained locations. So besides this, you would still be able to run your favorite AWS services locally. So you can still use Outpost to run EC2, EKS, ECS, and other services as well. From a use case point of view, so with the new form factor, Outpost can help customers operating across smaller sites, for example, in retail, with healthcare providers, with even factories or warehouses, where you can use them at the edge to basically perform any sort of integrated IoT data or monitor systems or provide feedback to operators. We also launched a number of new features and services on our Outpost. For example, AWS Outpost now includes option for supporting the latest generation of Intel-powered EC2 instance types with or without local instance storage. We also offer the general purpose M5D instances that essentially provide a good balance of compute, memory, and network for your general purpose workloads. But at the same time, we have also optimized C5 and C5D instances that are basically used for high levels of compute intensive workloads. But at the same time, they deliver cost effective performance at a very low price. Besides this, we also announced support for Amazon Elastic Cache on Outpost. So this enables sub-millisecond responses for real-time applications, including workloads that are running on factory floors or within hospitals for real-time patient diagnosis, media streaming, so on and so forth. We also announced the availability of Amazon S3 for Outpost. So now you can store object data on-premise using the same S3 APIs. So S3 on Outpost provides a new S3 storage class, which is called as S3 Outpost, which uses the same APIs, and it is also designed to provide 99.99% of durability with the help of redundant storage access. S3 for Outpost will also provide flexible options to control whether your data is stored locally or in a particular AWS region. And last but not the least, we also introduced the general availability of Amazon RDS on AWS Outpost. So as of date, RDS on Outpost supports MySQL and PostgreSQL with support for additional databases coming soon. So this essentially will provide you with cost-efficient and resizable database capacity while automating your time-consuming administrative tasks like provisioning the database, setting it up, patching, backing it up, all of these type of additional tasks. With that being said, I hope you had an informative first half of the recap session. We will be breaking for a couple of minutes and then starting off with Vincent's quick overview of the networking and security announcements. So don't go anywhere. In the meantime, if you have any questions, please feel free to write them down in the chat or in the questions box. I'll be more than happy to answer them as well. So thank you. And yeah.
So hello, everybody. So thank you for joining us this morning. So I will continue the session today. So we have, I think, 45 minutes left until lunch. So yeah, hopefully you will enjoy this second part as well. So this second part of this re-event recap is focused on networking and security. So with a focus on networking security, in fact, and yeah, I've selected I think the most relevant services and features that could be interesting for you. So let's begin and let's make a nice transition with Johan's presentation, and let's continue to speak a bit about AWS Outposts. And in fact, I wanted to point out an announcement that has been released on the 21st of December last year regarding how an outpost can be connected to a home region, so to a home AWS region. So basically, before this announcement, what you could do is to connect your outpost with one of two solutions. So, or you could use the public internet, so quite simple. Or you could use an AWS Direct Connect. So as you know, Direct Connect is a leased line, so between your premises and the AWS region, but it could only be done via a public virtual interface, which means concretely that you would need public IPs. So in fact, in these two cases, public IPs were needed. So with this new announcement, so from end December, what is now available is that you can connect your outpost to your AWS region via private IPs. So in fact, you can use a direct connect with a private virtual interface, and so with this, in fact, it increases the security because you don't rely anymore on any IP address. Everything is totally private from your on-premise environment to the AWS region. So next, I wanted to touch a bit upon the Elastic Load Balancing service. We have seen, with customers and in the IT in general, that the workloads are located in multiple places. So you see. We have workloads in data centers, so it's more the traditional way, but we have also in branches more and more, in mobile, at the edge, and in the cloud, so in AWS. We also have more and more different compute types. So we had back in the day, so the instances, so the EC2 instances first, so virtual servers, virtual machines. Then we evolved to containers and even to serverless. So as Johan explained, there are multiple services that can help you for container and serverless workloads as well. And then in terms of application types, also we have a multiple choice of application types that are available. So we have the web services, traditional web services. More and more applications are running on mobile. You have also the IT enterprise applications, IoT, virtual appliances, and so on. So we have really a great choice of different workloads, and it can in fact get more harder to manage. For that, for all these workloads, what we have done is also we have launched with the days multiple load balancer solution. So we began, in fact, with a classic load balancer. So it was our first kind of load balancer available. And then we evolved to two other types. So the network load balancer, which is more focused on HTTP workloads, so layer 4 of the OSI model. And we also evolved to application load balancer. So we propose another service called application load balancer, which is more for layer 7 of the OSI model. So all of these load balancers are highly available. They scale through auto scaling, and they provide also security features such as certificate management and so on. So you can use, in fact, all these load balancers for multiple targets. So the EC2 instances, containers, serverless. So that's really the goal of this portfolio. So with this small introduction, I wanted to just give you an overview of the enhancements that have been released throughout 2020. So not only during the reInvent, but just make a quick recap of all nice features that we have released in 2020. So the first one is the availability of the application load balancer on AWS Outpost. So as Johan said, he has already spoken about it in one of his slides, but here, it's just a reminder. Then we have also released the AWS Load Balancer Controller, So which is in fact it essentially replaces the application load balancer ingress controller. So for the people who have already used it, so this is in fact something that is coupled with Kubernetes, and basically it's like a version 2 of this application load balancer ingress controller. And with this second version, we have added new features. So one of the features that has been added is the possibility to use an application load balancer across multiple applications in your Kubernetes cluster. But we also released the possibility to have to use network load balancer to natively support to natively load balance services running in Kubernetes pods. So network load balancer can be used with Kubernetes pods. And then on the right side of the slide here, you see some of the features that have been released as well. So we have the support, so the network load balancer supports the IPv6 clients, in fact. So you can have IPv6 clients contacting your load balancer, and then in the backend, you can keep your servers running with IPv4. So the NLB can make the translation here. We support also UDP now for IP targets. So previously it was only so UDP was only supported for instance types. Now it's also for IP targets. We have also the IP session affinity. So for network load balancer. So with IP session affinity, in fact, this means that if there is session affinity, the same client will always be routed to the same target in the backend by the load balancer. And then the last one on the feature side is the support of gRPC, so which is more a protocol that is used, that is becoming quite a popular choice for microservices integrations and client-server communications. So yeah, these are some of the features released, and then the two others here are more on the security side. So we have mitigation for desync attack, and we have also the application layer protocol negotiation. So which is just a support of the TLS extension that allows application layer to negotiate which protocol should be performed over a secure connection. So yeah, these are some of the nice announcements that we had in 2020. So a bit. So this is here still linked to the load balancers, and this is here a new announcement that has been made not during reInvent, but it was in November. So it's I would say a big announcement. And yeah, as I said, it's also linked to the load balancer portfolio. In fact, you probably have, so all of you, all of the customers in general have already invested quite heavily for some in physical appliances. So physical appliances, for example, firewalls. So firewalls, like the well-known third-party vendors like Checkpoint, Palo Alto, Fortinet, and so on. So I have more names on the next slide, but you have probably already invested in these vendors to secure your on-premises environment. Probably you have also other types of physical appliances like intrusion detection appliances or network analytics appliances. You would like to be able to to keep these technologies, because you have already invested in terms of money, but also knowledge of your teams, and you have also maybe tools that integrate with these third-party vendors and so on. So you would like to continue to keep using these third-party vendors, but so on premises, but also you would like to be able to migrate them to the cloud, to AWS. On the other side, as we discussed the load balancer portfolio, you probably like these services. So the NLB is quite a nice load balancer that can scale easily and that can bring resilience in the cloud. So why not couple both together and also keep this load balancer transparent to the network traffic? So that's what we in fact tried so we listened to the customer, and in fact we have launched a new feature which is called the AWS Gateway Load Balancer, so to tackle this challenge. So as the name implies, so the AWS Gateway Load Balancer is in fact a combination of two entities, I would say. So there is first a gateway, and then there is a load balancer. So the gateway first is something that you will be able to deploy in your VPC. So let's say you have EC2 instances in a VPC. You will be able to deploy a gateway load balancer endpoint, similar to, if you know, the internet gateway or a VPC endpoint. It will be very similar. So it's something that you deploy in your VPC. And then with this new endpoint, you will be able to manipulate the route tables of your subnets inside your VPC to point routes to this endpoint. And then in the backend, you will have a load balancer that will be able to load balance to your virtual appliances. So I have a diagram just on the next slide, but just to let you know here that we have a certain amount of partners, so 14 partners for the launch of the Gateway Load Balancer. So if you recognize your vendor here, so as you can see, we have quite famous names in terms of firewalls and security appliances. So if you are using these, and if you would like to be able to use them in the AWS cloud. In fact, all of these vendors have already published blogs where they explain how they integrate with the Gateway Load Balancer. So let's have a look visually at what the Gateway Load Balancer offers. So first, without the Gateway Load Balancer, this is basically how you had to configure and to install, I would say, virtual appliances in AWS. So basically, if you had a source and a destination, and you would like to have firewalling between these two instances, you would have to redirect the traffic to a pair of appliances. So this can be a pair of firewalls, for example. And because of the implementation details that are required by these firewalls, usually you will you would be limited in an active-passive setup. So usually you will have only, even if you have two virtual appliances in the cloud, only one of them is active. So you lose, I would say, one appliance which just stays in standby. So the passive appliance sits idle as written here. So you have also a limited scale because you have only one appliance which is active in the end. So you have a limited throughput. You have a limited number of concurrent flows. This limits the scale. You have also a central point of failure because, in fact, you have an active-passive setup. It's nice, but what if both appliances fail? So, in certain cases, it could really be a point of failure. In fact, this pair of appliances. Also, yeah, if you have already implemented that yourself, yeah, you know that the configuration is quite complex. You have to work with source netting and also sometimes tricky scripts to make things like high availability and failover possible. So the configuration is not really the simplest possible. And the last point here is that you have also a mixed admin domain, in the sense that if maybe you have a networking team and a security team, these two teams have to work together, because there are things to do in terms of routing in the security appliances. So so a lot of challenges. It can work, but there are drawbacks with this solution. So the gateway load balancer begins with the endpoint. So as I said, the endpoint will be like an internet gateway or a VPC endpoint. It's another kind of endpoint that you will be able to have as a next up in your route table, and so you will just be able to use that as a layer 3 endpoint to route your traffic to the gateway load balancer endpoint. And then on the back end, what you have is the possibility to have now an appliance fleet. And that's the main difference. As you see here, it was a pair. Here it's a fleet. So you can have 1, 2, but also 3, 4, 5, 6, and it will horizontally scale. So this is where we use the power of, I would say, of the load balancer. So you have a higher availability, you have horizontal scaling, you have this load balancing. It's totally transparent also, so there is no need to have a very complex configuration to make it work. And so the partners that I've presented before integrate already with the gateway load balancer, and these are fully supported partners. And in the end, it's fault tolerant, because if you have a fleet, if you have I would say 3, 4 firewalls, if one of them fails, then you can continue with 3, but you can reprovision automatically a 4th one. So there is no central point of failure anymore with this. So this is here an example of an architecture that you could have built with the gateway load balancer. This is just an example, so I'm not going to do a deep dive in our possible architecture, but it's just for you to have a sneak peek on that. So we have also blogs explaining other architectures, and we can also have a specific session if you are interested in using that. We can also have a dedicated session together to deep dive more in architectures. But here, as an example, it's an architecture to be able to do north-south filtering, so firewalling. So traffic comes from the internet, goes to the internet gateway, is redirected to the gateway load balancer endpoint. It goes to the gateway load balancer, so in this case it's the load balancer, that goes to your firewall fleet. And as you can see here, there is an encapsulation which is done by the gateway load balancer. So in fact, your firewall needs to support the type of encapsulation, which is called, it's using the Geneve protocol. And from there, in fact, the traffic can be firewalled, I would say, and then come back to your instance. So here, in this case, it's you have the case with multiple VPCs, and then the firewall will be able to make the difference thanks to the different encapsulations. Another integration of the gateway load balancer is with the transit gateway. So the transit gateway is a routing object that you can use, and a lot of customers like the flexibility and the centralization of the transit gateway, and the fact that it's also highly available behind the scenes. And so you can here couple the gateway load balancer with the transit gateway to have a more centralized architecture. So in this case, it's also for north-south inspection. So traffic comes from here, the VPC 4. So it's an internet VPC. So it comes here, then it goes to the firewall fleet, and then comes back to a VPC. So yeah. But yeah, so the gateway load balancer is great, I would say. So it really simplifies how you deploy your third-party vendors' appliances in AWS. But some customers wanted more, in fact. So what they asked us is really to build a firewall service totally managed by AWS, so that they don't need anymore to use third-party vendors. So some of the customers have this requirement, and basically, so with the AWS network firewall that we have released, it was also in November, so just before the reInvent, it completes, in fact, the portfolio to secure your VPC. So with your VPC, you know that a VPC, it's already something that is totally logically isolated in the cloud. So it's your part of the AWS cloud. We had already the security groups and network access lists. So security groups are stateful, access lists are stateless. So layer 4 of the OSI model for security groups and layer 3 for the access list. So which was already good, but yeah. Customers wanted more advanced features, so I will give a bit of details about the features in one of the next slide. But yeah, security groups and network access lists, it was not enough for some customers. So we had also NAT gateway. So you know, NAT gateway is just to be able to give access from a private subnet to the internet. And allow the returning traffic, but not in the opposite way. So internet cannot initiate a connection to your private subnet. So we had that as well, but then network firewall is there to complement this portfolio, I would say, of features. So what is the network firewall? So basically, the network firewall is a firewall that works across, so it's really across the layers 3 to 7 of the OSI model. And it can inspect traffic between your VPCs, traffic between a VPC to the internet, from the internet to your VPC, and from or to your VPC to your on-prem network via direct connect or VPN. So it can be really put in the middle of these flows. So yeah, again, we partner with some companies who bring some features to the network firewall. So I will detail that in a subsequent slide as well. But basically, yeah, the network firewall is something, is a firewall that is totally managed by AWS. So basically, this slide shows you a bit what you have to do and what AWS is managing. So at the top, you see that the only decision you need to make in the end is where to place the inspection point. So this inspection point will have to be put in your VPC. And in fact, in the backend, the network firewalls uses the gateway load balancer. In fact, so we use the same load balancer in the backend, but the only difference is that it's now with the AWS network firewall. It's not with a third-party vendor, but in the end, it's the same principle that is in the backend. So you will just have to decide where to place your endpoint, so in your VPC, and decide which policies have to be you want to apply. So basically, the firewalling rules. And then, it's also possible to integrate the network firewall with Firewall Manager if some customers are already using that. So it's also possible to integrate so that you can have a single pane of glass with Firewall Manager to manage your AWS network firewall, but also your security groups and also your WAF, web application firewall, if you are already using WAF. And then in terms of AWS, what is AWS doing? So it manages everything for you in the backend. So your firewall will scale automatically. So no worry about scaling anymore. So everything is managed by us. You have a throughput performance of over 45 gigabits per second, so which is quite a nice throughput. We have also managed zonal affinity. So if you use multiple availability zones and session symmetry is also there. And we have a nice SLA of 99.99%. So that so it's a guarantee for you. In terms of features, again, I'm just going to do an overview, and focusing more on this part. So what are the main features? So the two first ones are layer 3 of the OSI model. The two next one are layer 4, and the two last one are layer 7. So the firewall really works across layer 3 to 7. So first one, layer 3, quite easy. In fact, you can have very large IP lists. So you just make a list of IPs and you can block or allow them. So when we say large lists, it's in the range of tens of thousands of IPs. So yeah, quite handy. So this is layer 3. We have also the stateless rules. So the stateless rules are just rules that you can deploy, and in fact, these rules refer to the 5-tuple. So in fact, to create a rule, you just put a source and destination IP, a source and a destination port, and then the protocol. So that's the 5-tuple. Then for the layer 4 possibilities, so features, we have, it's a bit the same. So you see we have a stateless engine and a stateful engine. So the stateful engine is the same as the stateless one, except that we are adding also the direction of the traffic is taken into account there. So the firewall knows if the traffic is going in, to one direction or the other, and it can keep track of the sessions. So it's stateful rules. We can do also FQD and filtering. So it's on HTTP and HTTPS. So this is really, these two are for layer 4, and then for layer 7, we have also the protocol detection. So in fact, you can create rules, but it's not mandatory with these rules that you specify a specific port. So in fact, the protocol can be detected automatically. So the protocol at layer 7 is detected. So it's a layer 7 feature. And then the last one is, you can also create rules for IPS and IDS, and it supports an open source rule format called Suricata for people who are familiar with that. For the rest, in terms of visibility and reporting, the firewall is integrated with CloudWatch. You can send your logs to S3, CloudWatch logs, Kinesis firewall. So the nice integration with other services for visibility and reporting is there. And in terms of central management, I already said that the AWS Firewall Manager is supported. So you can manage the AWS Network Firewall via the AWS Firewall Manager, And we have also integration with CloudFormation, Terraform, and the Resource Access Manager as well. In terms of partners, so these are in fact the partners split by features, I would say, so split by features that they bring to the AWS network firewall. So in terms of security monitoring, we have companies like Splunk, where you can send your logs, your firewall logs to Splunk devices. as an example. You have threat intelligence. These are really partners that help you make your rules. So they can offer rules that they create themselves, and then you can use them to configure your AWS network firewall. There are also partners for policy management and managed security. So maybe you can recognize some of them. Okay, and in terms of architectures, again, there are a lot of possibilities on where to place the network firewall. But here, in fact, as you can see, it's the same architecture as I showed you before with the gateway load balancer, except that here, instead of having third-party firewall, it's the AWS network firewall. So, but the rest is exactly the same. You see, we have endpoints here. So these are called firewall endpoints in this case, and not gateway load balancer endpoint, but that's the same principle, in fact. And here we have north-south filtering. Exactly the same with the transit gateway integration. So we can have also transit gateway there, and have this inspection of traffic coming from the internet going through the transit gateway, the firewall, and then come back to an instance in a VPC. So we can have north-south, so from and to internet to a VPC, but also between VPC. So that's east-west and north-south are supported. And then this slide is just to make a quick recap of the multiple security features that we provide now with the addition of the network firewall. So yeah, the slides will be shared afterwards, so you will be able to have a look at that more in details yeah, after the session. Okay, with this, let's continue because we have something like 12 minutes left. So the next one is about private link. So private link, maybe you are already using it, but as a quick reminder, what is private link? Basically, you have the AWS cloud, you have your VPC, and you have an instance, for example, in your VPC. You would like to be able to contact other services from your EC2 instance in your VPC. Let's say you would like to contact, for example, SageMaker. But SageMaker, as well as other services like these ones here, are public services, which means that they can be reached only via public IP addresses by default. So normally you should have, in this case, to be able to connect to public services, you should have a public IP on your EC2 instance. And then traffic will go through an internet gateway, and then you will be able to reach the services. Yeah, so it's something that works, but you need a public IP. So some customers don't like public IP, for the security. So what we do in this case is we change the public IP by a private IP. And then we use what we call a VPC endpoint. So that's the private link is the usage of a VPC endpoint. So it's another type of endpoint. And with this, in fact, the traffic that goes through the endpoint stays private, and you can use this private IP, and you don't have to rely on public IPs anymore. So yeah, private link is something that we have released quite some time ago, and what we are doing is increasing the number of services that support the VPC endpoint. So basically, we have now more than 99 services, and in 2020, we added Lambda, Redshift, and more. And as Johan explained also, so S3 VPC interface endpoint for S3 will be released soon as well. Now, in terms of Transit Gateway, so Transit Gateway is it's a service that we released in 2018, so 2 years ago now. And it's a service that has a lot of success because really the transit gateway can help you in the sense that it becomes a hub, a networking hub for the traffic between VPCs, but also between VPC and your on-premise network via a VPN connection, or also via a direct connect gateway. So that's really a central hub, which is what is nice is that it's really, it acts as a cloud router. So it's something that seems centralized, but in the backend, under the hood, it's totally it's a distributed system, I would say. So it's not a single point of failure, and you don't have to manage it. So we take care of this distributed system for you, and you only see that as a router, in fact. So this service has a lot of success, but in parallel of that, we also see more and more customers deploying SD-WAN, so software-defined wide area network solutions. So these solutions, SD-WAN, are deployed to manage your branch-to-branch or your branch-to-cloud connectivity. So at the same time, some customers also use the transit gateway as their network hub between on-premises and AWS to build, in fact, their global network using the AWS backbone. So they really use the AWS backbone to have a global presence to improve the reliability, the performance and the cost. So basically what we wanted to do is to go further and to make a stronger integration between the AWS Transit Gateway and the SD-WAN providers, so partners. And so that's why we have released the Transit Gateway Connect feature, which really goes forward with the integration between these SD-WANs and partners and the transit gateway. So basically, just very quickly, visually, how does it work? So let's say you have a transit gateway with some VPCs that you have, and you have your data center with some branches here, and you have a VPC where your third-party appliances are located. So before Transit Gateway Connect, you had to use a VPN between the two. So the configuration was not so smooth, and a bit complex. So with Transit Gateway Connect, the main difference is that this link between the Transit Gateway and the SD-WAN partners is not a VPN anymore. So we can have, in fact, dynamic routing. So BGP is used between the Transit Gateway and the third-party SD-WAN hub. Okay, let's move on. And just for this announcement, so Transit Gateway now supports IGMP. So last year we released multicast for Transit Gateway. Now we have IGMP support as well. So probably if you have multicast applications on premises, and if your application is using IGMP and you would like to migrate to the cloud, now it is something that is possible. Okay, so with that, I think we can do a quick poll. So I've discussed a bit of a certain amount of AWS services. I would like to be interested in knowing which one interests you. So, or the gateway load balancer with third-party vendor, or the network firewall, private link, Transit Gateway Connect. You can choose multiple options. But it would be nice to have an idea of which service or feature you are interested in. And then after the poll, I will just have 5 minutes to finish, but it will be feasible. So Okay, so it's so it seems that the AWS network firewall is something that interests you. So great. So the private link, yeah, there is no surprise. So there is more and more, the customers ask more and more for a private link to have these private connections between EC2 instances or other services inside the VPC and public services. So there is no surprise here. I see that Transit Gateway Connect is also something that is seems to be interesting. So I would say if you're interested in, I see Network Firewall, Transit Gateway Connect. If you want to have a more deep dive session where we do, for example, a demo or we go more deep dive in configuration and so on, just reach out to us, and I'm happy to organize a session specifically on that for you. So thanks a lot for that. And then we are going to finish in 3 minutes with the last announcements regarding management and monitoring. So basically, in terms of management and monitoring, it's very important to have services and visibility in what is happening in your network. So this is why, it was last year we have released the Transit Gateway Network Manager. So basically, visually, it can provide you this kind of nice view on the links that you have on your transit gateways and so on. It can send alerts to CloudWatch events to so that you can have alerts and take actions on things that happen in your network. For example, a BGP peering that goes down or things like that. So Transit Gateway Network Manager is a really nice feature. Then in terms of visibility, we also have the flow logs, VPC flow logs. Probably you know them if you have already used VPC. So the flow logs give you metadata about your traffic. So these are the kind of things that you can have. And we also provide more metadata like the VPC ID, subnet ID, and so on. So this year we have released more metadata. So the metadata are the region, for example, the availability zone or outpost, the local zone, if you use local zone. So we have expanded the number of metadata available. And also interesting is that the granularity has been decreased from 10 minutes to 1 minute. So for troubleshooting, it's a nice addition as well. Flow logs is good, but it just gives you an overview of metadata of the traffic. If you really want to capture the whole traffic, the real traffic, in fact, what you can use is the traffic mirroring feature. And as you can see here on the animation, you can have traffic totally mirrored to another instance, which can be a monitoring instance. So you can use your own traffic analyzer, open source traffic analyzers, or partners as well. And for that, we have released new integration with CloudWatch metrics. So for example, you can now have metrics about the number of inbound, outbound bytes and packets that were actually copied versus the number of packets that were not mirrored because there could be any specific issue. So you have more visibility in that. Just before finishing, this tool, so the VPC Reachability Analyzer, it's a new tool that helps you in troubleshooting connectivity between, for example, instances in your VPC. So concretely, let's say you have a source and a destination, and traffic is not flowing correctly. In fact, this tool helps you in the troubleshooting in the sense that it will detect that, the flow is not going because you have a problem with this specific security group. So it really helps you troubleshoot. And in the end, when everything is fine, you have a nice view of how a packet is flowing from an instance to another. So you see the instance, the interface, security group, access list, route table, internet gateway. So you see the whole flow in a single pane of glass. So very nice. And to finish, so I'm just a bit over time, but just very briefly to finish. So we have also introduced the instance level network monitoring. So basically, what is it? Is just an enhancement of the network monitoring at the instance level. So before this enhancement, you had some metrics like the network bytes and packet utilization. Now we have extended these metrics, and you can have things like the bandwidth capability, the number of packets per second, the number of connections that can be tracked by the instance, and so on. So there is also a blog post giving you more details about that. So yeah, so with that, I'm out of time, so it's lunchtime for you now, so for everybody, in fact. So thank you very much for your your attendance today. So we will have also, if there are questions, unfortunately, we are out of time. So we are going to check all the questions and reply to the people who have asked questions. So if you have additional questions that come maybe this afternoon, feel free to send an email. And again, we are happy to answer or to have a dedicated session to understand your use case and help you with an architecture. And yes, don't forget to join us also on Thursday. So it will be exactly at the same time, so between 9 and 12. So this Thursday, so it will be the 28th of January. And we will have a focus on databases and machine learning and artificial intelligence. So again, thank you very much and have a nice day.